So we're recording now. That's good. So I'm going to go ahead and what I'm going to do when I'm teaching this class every day is I'm going to just type things into the command window. So I will not be putting things into an M file like you might do. I'm just going to type it into the command window. Can everybody hear me? Can you guys hear me in McCook?
Yeah.
Okay. Can you hear me there? Are you in Ogallala? Is that right?
Oshkosh.
Oshkosh, that's right. Okay. Can you hear me there? Good.
Yeah.
Okay. So let's go ahead and get started. First off, I'm going to start you off with one of my little tricks that you can learn here, and that is the clear command window command. Clear command window is CLC. If I just type CLC into my command window and hit enter, it clears everything I've written in that command window in this entire session and leaves it blank. There's another one that I'm going to show you, which is to clear all. This is just the clear command, and what it does is it clears your workspace. Over here I have a workspace that says that A equals 4 and answer equals 25. So if I use A up here, if I type A into my command window, MATLAB knows that that equals 4. And if I type in A and S for answer, it knows that that's equal to 25. So if I type A plus 6, for example, it tells me the answer is now 10, and it has changed answer to 10. Answer is just the default variable. We call these things variables over here. But A and S is the default variable for whatever is the latest computation MATLAB has done. And I can assign variables different names. I can assign different letters for different variables, like A equals 4, by just putting in A equals 4, and it saves it in my workspace. But while those things are in that workspace, MATLAB just uses that information here. Now if I say that A equals 6, I can reassign A and make A equal to 6 now instead of A equals 4. And over here in my workspace, it has changed it to A equals 6. But the best thing to do when you're starting over is to just clear those out so that you don't have any residual data kicking around, because it can get confusing if you don't know what's kicking around over there. If you just have a long list of things in your workspace and you accidentally use A again and don't reassign it to something else, then your computations may be incorrect. So I usually just like to clear all, and that will just clear everything over in my workspace. And then I like to do a clear command window, CLC, and clear my command window. Just makes everything nice and clean.
If you spot, can you undo or no?
No, if you do either of those things, you can't undo them because it's RAM memory. Once RAM memory is erased, it's lost. So don't do things in the command window that you want to keep. If you want to keep it, come up here to your editor and type it into an M file. Right? If you want to keep it, do it up here. If you're just trying stuff out, do it down here. But because I'm just showing you things after thing after thing after thing, I'm usually going to use the command window. There will be, well, at the beginning here of class anyway. Later on in class, we'll be using the M files a lot more. And of course, you will use an M file to record all the stuff that I do in the command window and take notes. But if you want to save something, you definitely want to do it up here. Another thing that you can do from the command window that's useful is you can close things. If you have a whole bunch, for example, if you have a whole bunch of things open up here in your editor, and I close all those things, well, actually it's not the editor, it's the image window. When we're doing MATLAB, if you have a bunch of images open that you've created and you want to close them all, you can hit close all, and it will close all those images. And I'll just clear my command window again. But this just gives you kind of a clean slate to work with in your command window, and then the clear all gives you a clean workspace to work with as you're programming things. So let's start off by just doing some basic mathematics. I've already done, basic arithmetic, and I've done, used parentheses a little bit, order of operations. But there are some functions that are included in MATLAB that it already knows. We already did the 5 squared one. You know that command now. But there's also a square root, and it looks like this: square root, parentheses, and you put in whatever number you want to take the square root of, and then you hit enter. Square root of 56 is 7.484833. And I could also do a equals 16, for example, and hit that. But every time I hit enter, I get this extra line where it says, oh yeah, a equals 16. What if I don't want it to print out a equals 16? I can actually suppress that printing by saying a equals 16 and put a, whoops, a equals 16, and put a semicolon after it. No, a colon. Actually, semicolon, yeah. So if I put a semicolon after that, that command means suppress printing to the command window. It will not print anything to the command window. When I hit enter, it'll just give me the next line, the next command line. This little double pointing arrow to the right is what we call the command prompt. That means that the command window is ready for a new command. If it doesn't give you that, it's not ready. It's either waiting, or it's stuck, or it's computing, or whatever else. If it doesn't give you the command prompt, you can't put in new commands. So that command prompt is important. You can put comments in the command window, at least you used to be able to. Yeah, you can put comments in the command window, like comment, this is really cool. I just love programming, right? And it just won't do anything, just because it ignores that line, and that's fine. You can also put multiple commands in a line of MATLAB in the command window, but I wouldn't recommend it. People do it from time to time. They'll say A equals 16, then they'll do B equals 4 or something, and that's fine. You can do that. MATLAB knows how to deal with that, but I wouldn't recommend it. It gets kind of confusing sometimes. So try to avoid doing that in the command window. But now that I've got all these assignments, I've got A equals 16, B equals 4, for example, I can actually use square root with one of my assigned variables. So it can be square root of A, for example. Square root of A is 4, because it knows what A is. I can even do, and here's another trick that you may have seen me do earlier. If I'm in my command prompt and I've got a cursor blinking, I can hit the up arrow, and it'll show me all the commands that I've done in the last little while, usually for the last day. It'll show me all the commands I've done since I've opened MATLAB. And so I can choose one of those. Let's say I want to choose the square root of A, then I can just go to that, and then I can change what's inside. I can do the square root of A plus B, for example. So I can add inside the square root, perfectly legal. And it will do that too. It will add the A plus B inside the parentheses first, and then it'll take the square root of the result, which is 20. Square root of 20 is 4.4721, and we're good to go. So basic mathematical functions are all included. And that also includes things like it knows what pi is. Pi is 3.1416, and it actually knows it out to many more digits than that. But right now MATLAB is set to only show 4 digits. So I can do things like the cosine. The cosine of pi. What is the cosine of pi? -1, right? It knows that. And I can do pi divided by 4. It knows, oops, pi divided by 4. There we go. Now I've assigned pi to 4. Now that's confusing, isn't it? Before I said that pi was equal to 3.14159, whatever. MATLAB does know that, but it will allow you to reassign pi. And I just inadvertently reassigned pi. I said pi equals 4. And so now I've said that pi is equal to something different. MATLAB will let you do that, so you have to be careful. The things that are pre-assigned values in MATLAB, you want to avoid assigning them new values, either on accident or on purpose, because it can really mess you up. So I'm going to clear all those things in my workspace, and I'm going to hit pi again and see if it's made it right. So pi is, again, 3.1416. Or I could say that pi equals 10, not minus 10, and reassign it, and then I can actually say, okay, I'm going to erase this. So if I go up here and select this, and if I right-click on it and I delete it, it'll delete that variable, and I can go back down here and I can go pi equals, and it'll be back to where it was originally. There's a couple different ways to fix that if you do that on accident. But we can also do for example, the sign of pi halves. Divide pi by 2 and see what you get. Sine of pi halves is equal to 1. It knows that too, right? The problem with some of these variables that are built into MATLAB is that they are exact numbers in MATLAB. They are not the exact number pi, because pi has no exact number. It has an exact definition, but there's no number that you can write down that is exactly what pi is, because it is a what do they call that? An irrational number? Irrational numbers do not have an exact value unless it can be written as a fraction, which pi cannot be written as. Pi cannot be written as a fraction, so we're kind of stuck there. But pi is really it's just the ratio between the circumference of a circle and the diameter of a circle. That's what it is. That's the definition of it. And so it has no real actual value that can be written down exactly. So when you use pi, sometimes you're going to get an inexact answer in MATLAB, and you have to be aware that that will be the case. For example, if you took the sine of pi thirds, for example, take the sine of pi thirds, it might give you 0.499999 instead of half, right? So is it pi thirds or pi fourths? I can't remember, but whatever it is that's supposed to be 1/2. It might not necessarily give you the exact answer, and that can happen. Okay, so what other things can we do here? What else can we do that's new and different than we've done so far? All right, let's build an array. So now we're over on page 14, and we're going to show you how to build. In MATLAB, we call a matrix. We also call them arrays sometimes. Usually, array is used for a matrix that is only has one row or one column and multiple of the other. But sometimes people just use them interchangeably. A matrix is an array is a matrix. And I will do that all the time. Also, in MATLAB, sometimes we call them vectors. A vector is sometimes used synonymously with array or matrix. So you have to be aware of that. Vector, array, matrix, they can all mean the same thing. They're just an organization of numbers into some kind of grouping that has, order to it. First row, a first column, a third row, whatever. But let's do a very simple one. Let's start off with, we're starting on page 14 here. We'll start with an array B, capital B. We'll use to, and MATLAB is case sensitive. It does know the difference between capital B and lowercase b. So you have to be aware of that and be very careful with that. But we're going to build an array of numbers a couple of different ways. First of all, I'm just going to put some numbers here, 1, 2, 3, 4, with spaces in between them. MATLAB does understand spaces, it does understand delineations, it does understand things that are separating numbers, but it understands them in very specific ways. So let's see what MATLAB says about this. I'm going to go ahead and suppress the output. Well, no. Let's see, what did I do here? MATLAB used to understand that. Apparently it doesn't now. Okay, so let's try some delineations. Let's try to separate them with commas and see if it understands that any better. Yeah, so it does. So B equals 1, 2, 3, 4 gives us an answer, B1, an answer is 2, an answer is 3, an answer is 4. And over here, if we go into B, we see that it's given it the value of 1. And that's it. So it did something, but it didn't do maybe what we expected it to do. It seemed to have saved just one number. Remember, you need to be careful when you're closing variable windows or anything else that you don't use the red or the close box that's up here on the left for a Mac or on the right for a PC. Use the one that's inside this little bar here, right above that box, because otherwise you'll close the whole MATLAB window. So it didn't do what we expected. It did give us these answers, 1, 2, 3, 4, but it only saved one of them to our workspace, just the one. And so that's maybe a little different than we expected. And the reason for that is because MATLAB is not really designed to recognize numbers that are put into some kind of order without telling it that it's going to be an array, matrix, or a vector. So how do we tell it? We tell it by putting some square brackets around it. So use the square brackets and then push enter, and now it has put them all into a group, an array, a vector, a matrix. And if we go over here and click on B, now this is what it shows us. It shows us an array or a matrix or whatever that has one single row and 4 columns, 1, 2, 3, 4, right? Put those numbers into those spots. In a matrix like this, we call these cells, or we also call them, what's the other word they use besides cell? Components, maybe? Components in the matrix? Yeah, I think maybe components. I can't remember. But anyway, we'll come across a couple of different words for those individual boxes where the numbers are. So now we've made an array. We've made a matrix of numbers just by putting square brackets around it, and we put commas between the numbers. But let's try something else. Let's go to our previous one that had no commas between the numbers, and let's put brackets around that and see what happens. See if MATLAB understands that. Hit enter. Turns out that it gives us the same thing. 1, 2, 3, 4. So MATLAB recognizes numbers with commas between them and numbers with spaces between them as an array of a single row with different components, with different entries in each of these cells, right? Boom, 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 1, 2, 3, 4. So it recognizes them the same way. So when you're building an array of one row with several columns, a single row array or a single row matrix with several columns, you can do it either way. I prefer just to use spaces because it's faster, I think. But you can do it either way. But there's another way you can build an array. We can actually go over here and right-click on the workspace and select New, and it will create a new unnamed array. Or we can go up here to New, and we can choose a new, no, it won't let you do it up there anymore. Never mind. But we can go here and we can right-click and choose a number. We can name it. We can call it named now. Now it's named. Or you can give it a letter or whatever else you want. Don't assign it to a number. MATLAB will not allow you to use numbers for variables, but you can use letters. You can use a word for an array that has a number in it, so I can call it named 4, and that's acceptable, but it can't start with a number. So very similar restrictions in naming variables as you have in naming files. Then I can go ahead and hit return, and right now it's just a single celled array with, and it just, they put 0 in that cell just as a placeholder, but all the rest of them are empty. But I can go ahead and type numbers in here. I can select that and put in a 12. I can put in a 34. I can even put in my name if I want into there, and then I can go ahead and save this. If I close it, it'll ask me to save it. Oh, it doesn't like that. Let's go back to here. Let's put that in single quotes. When you're putting in text, it likes it to be in single quotes. It may not even let me do that. I can't remember what the new protocol is for that. So anyway, it wants, so what it's saying there is it's saying that it said that the dimensions are mismatched. What it wants is it wants the same kind of thing in every box. And there are ways to get around that. But since I put a word in one box and numbers in other boxes, it didn't like it. If I put quotes around all these, it would have been happier with it. But I can go ahead and fill this up. I can even put numbers here and have more than one row. And go ahead and save it. If I close it, then it shows me now it's a 2 by 2 matrix, 2 rows, 2 columns. And it even shows me what are in those rows and columns. This is the first row, this is the second row. And I can go down into my command window and I can type in named. Whoops, it's not named, it's named 4. Right? And I can type in named 4, and it'll show me that array. Gives it to me. So you can enter in arrays. If you want to enter an array of numbers that's a single column in multiple rows, then we do it like this. Let's do column 1. And let's set it equal. And I'll put in my square brackets. And let's do 2. And I'm going to put in, for the next row, I'm going to put a semicolon. I'm going to do 3, and then 6, and then 90, something like that. Hit return. And there's my column array. So go to column 1. You can see that it's giving me that column array. And I can add to it if I want. I can increase the number of columns by putting things in here. If I leave everything blank underneath it and don't put anything in it, it just automatically adds zeros, which is a nice feature actually. If I put something way down here, for example, and hit enter, it fills in the rest with zeros. And you can put negative numbers in. You can put all kinds of things in. And then when you close it, it's built a new array now. Now this array is 18 by 8. So that is how we enter in arrays. That's one of the ways that we can enter in arrays. There are other ways. If you want to enter in a multiple column and row array, we'll call this multiple column and array. Put our square brackets in there. You can do it a couple of different ways. One way that you can do it is you can put in your row 12, 54, 2, and then you can actually put in the next row would be a semicolon, 23, 7, 5, and you can put spaces between the different columns, or you can put commas. So if you put commas in instead of spaces, you just put commas here, 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 and here. In either way, it'll build you this multiple row, multiple column array. Or you could do the same thing, and instead of putting a semicolon in here, you can actually put, that's not what I meant to do. Okay, let's see, you can do, you can, before you finish up your array, before you put in your second square bracket, you can hit enter, and you can put in your second row. So I can put in 23, 6, 1 or something, and then close my array. And as long as I've hit enter before I close my array, it will recognize that as a second row. So there's lots of different ways to do things. Why would they have lots of different ways to do things? Well, first of all, MATLAB started as kind of a user community-based thing where people were just kind of building MATLAB as they went. And so different users, different builders building MATLAB were building it in different ways. And so it just came out with different commands for doing things. But also there are just a lot of different ways that computer programmers like to do things. Some computer programmers are very much into one way, and some other very much into another way. It's what they've been doing for years and years and years, and they can do it in their sleep, literally. Like they literally dream in code. It's kind of scary. But you have to cater to those kind of people because they're the ones that are buying your program. So you have to have different ways of doing things for them so that they can sit down and not have to learn a completely different way of programming. So that's the reason for that. And the computer programming world is a very, very particular world in things like that. It's something that if you program a lot, you'll learn about. If you don't program a lot, you probably never have to learn about it, and you'll be happy that you didn't have to learn about it. I'm not a huge programmer. I can't do it for very long before I go crazy. But I've been in that world a little bit, and you know, it's for a different person than I am. I don't have an attention span that can handle that. Anyway, so we've got some different ways to put in things, these arrays under our belt. Let's see, command window, document window, variables, graphics window. Okay, so the graphics window. Now we're going to learn about pictures in MATLAB a little bit. So the graphics window does not usually show up by default when you open up MATLAB. It only comes up when you're looking for it. And if you press on the plots button here, you get a bunch of options for plotting, but you have to first select a variable to plot. And so, for example, if I choose this one right here, which is a 2x3, it can plot it because it's a 2x3. An 18x8, not so easy to do, but it can be done. I mean, we'll do that one later. But let's do something a little more simple here. Let's plot B, for example. So B is a 1x4, and what it's going to do, what MATLAB is going to do, is it's going to assume that the index of your column is one of your variables for plotting. So the first column will be a 1, the second column will be a 2, the third column will be a 3, and the fourth column will be a 4, and that these values that we put in there are the actual values. So oops, that's not what I meant to do. So in other words, the index of your column, 1, 2, 3, 4 is your x value, 1, 2, 3, 4 is your y value here. And then it's going to go ahead and plot that. And let's show what that looks like when we actually plot it here. So let's choose a type of plot to do. We're going to choose B, and we're going to do just a line plot, and it's going to plot this, and that's what it's going to look like. For line 1, or for column 1, it has a value of 1. Column 2 has a value of 2. Column 3 has a value of 3. Column 4 has a value of 4. And notice that it started at 1, 1 instead of 0, 0. This is 1, 1, 2, 2, 3, 3, 4, 4. Unless you tell MATLAB to plot 0, it won't do it. So MATLAB does exactly what you tell it to do. But let's change it up a little bit. So let's actually go down to our command window. If you go to your command window, notice that that window disappears. And if I close all, it will disappear entirely. And if I look for it on my computer, it won't even be there. So it's just closed that window. So let's go ahead and plot this again, but let's change B first. Instead of 1, 2, 3, 4, let's change it to 1, 2, 2, 1. Oops. 1, 2, 2, 1. Oh, 1. There we go. So now I've changed my variable, and my x's will stay 1, 2, 3, 4, but my y's will be 1, 2, 2, 1. And let's go ahead and plot that and see what it does. So it goes from 1, 1 to 2, 2 to 2, 2 to 1, 1, or to 3, 2 to 4, 1, right? So it's still 1, 2, 3, 4 on the x-axis. Those are my columns, but my values are 1, 2, 2, 1. So it changes the shape of that plot. Now let's do something else with this plot window now. So one of the things that you can do with the plot window is if you go up here to this little black arrow, it allows you to, should allow you to, there we go, it allows you to dock that image into your your MATLAB window. So now it's one of my windows in here, right? And if I go up here to this little arrow here, I can undock it and bring it back out again, right? So the little black arrow docks it. This is the little black arrow, docks it. This little blue arrow gives you the opportunity to undock it, and so on and so forth. You can also close it from here and it just goes away. We can do other kinds of plots. We can do the bar plot for that particular variable. 1, 2, 2, 1, right? You can do a comet chart. What a comet chart does is it draws it out for you, but it was such a quick plot that you didn't really see it happen. We could slow it down, but I can't remember how to slow it down. We'll worry about it later. So there are a lot of things that you can just push a button and get when it comes to plotting. You can just push a button and get a plot, but you can also command it from the window. How do you command this from the command window? Well, we go down here to our command window, of course, and actually notice they've actually shown us the commands. When we just push this button up here, it actually put the command in. Plot B, bar B, comet B. It gave us those commands. So let's go ahead and do plot, but let's plot something a little more exciting. Let's plot this 2x2 here. Let's plot named 4 right here and see what happens. So named 4, what did it do? It says 12, 34, 12, 45. So apparently it plotted each row separately. This is one of the rows, and this is the other row. 12 and 45, 12, no, actually it plotted each column separately. Let's open named really quick. So it plotted the first column, and then the second column is what it did in each row. Oh, I did the wrong thing. There we go. So plot is a function that MATLAB has and MATLAB can do, MATLAB can deal with, but it starts to get a little bit crazy unless you understand how to use it. Because plotting that little array that just had 4 values and it made sense. This plot, we had to think about it for a little bit. It didn't necessarily make sense. So we have to start to understand what plotting is about. For example, let's make 2 new variables. Let's make a variable x equals, and we're going to make these into arrays. We'll make we're on page 17 at this point. We're going to make an array 1, 2, 3, 4, 5. And then we're going to make an array y equals 10, 20, 30, 40, 50. 10, 20, 30, 40, 50. And now we're going to plot, instead of just plotting one single variable, we're going to plot, we're going to actually plot x, comma, y. And what that tells MATLAB to do is it tells it to take the first thing that we made, which was x, and put it on the x-axis, put it on the horizontal axis, and then plot these numbers on the y-axis. So these are our coordinates, our x-coordinates and our y-coordinates for each point that we're going to plot. And MATLAB understands that syntax. So we go ahead and plot that, and it brings up a plot. Where's our plot? Well, it's not visible because we already have a plot window open. And whenever you already have a plot window open, it just puts the next plot on that plot window. So if it's already open and it's not docked, you probably won't see it right away. So I'll go ahead and dock it over here, make it a little bit bigger. So there's my plot. 1, 2, 3, 4, 10, 20, 30, 40, 50. All those plots are connected with a line. We can do different kinds of plots with that, of course. We go to plots, and we select, well, let's not even go to plots. Let's just go down here and do this again. Let's plot x and y, but let's do it as a particular type of plot. Turns out that plot, you can plot in different ways. You can do different things if you choose a particular thing. So I'm going to choose a star. Star is one of the things that allows you to do. I'm going to choose a star and I'm going to replot. So instead of plotting it as a line, it plots it as stars. It puts a star at each one of those points. 10, 110, 220, 3, 30. The default is just a line plot, but you can choose a star. You can also choose to put in a let's see, what else can you choose? I can't remember. Oh, you can choose to put in a dash line. No, that's not the dash line. It's double dash, I think. Yeah, you can put a dash line in by putting in a double dash. So every function in MATLAB is not necessarily as simple as it seems. Sometimes there's extra functionality, extra things that you can do within a function in MATLAB that are available to you, but you have to know that they're there. How do you know that they're there? Well, you take this class, and we'll teach you. But there's also another way to know that they're there. Whenever you come across a function in MATLAB and you want to know about it, you can type another function, which is called the help function, and you can type the name of that function that you're interested in. So in this case, help plot. And if you hit help plot, it'll bring up a little miniature help lesson on what plot can do. This will not tell you everything that plot can do, but it will give you the basics. And it's a little bit difficult to read sometimes because it's written in computer programming speak. So you have to understand some things about MATLAB and some things about mathematics. So it's not necessarily all that easy to understand it, but it does give you examples towards the end. And so that can be helpful. So here's some examples of plotting. They give you an example. And if you really want to know a lot more about it, then go to this doc plot, this reference page in the help browser, hit that button, and it'll open up a window that'll give you a lot more information and a lot more examples. And of course, if you really want to know a lot about it, you can go online, you can watch videos, you can do all kinds of things. So, that takes us through most of that. What time is it? 2:18. We've got to hurry up here. We're going to run out of time. I'm going much too slow today than I intended to go, so we're not going to get as far as I wanted to go. I wanted to get all the way through chapter 2, but we'll just have to finish up chapter 2 next time. But we will get through at least the next couple of things here. So one of the things that I've mentioned that you have to be careful of in MATLAB is your variable names, and here is a useful function. Isvar name. So isvar name is a function that checks the name of your variable to see if it's a good variable name to use in MATLAB. So let's say that I want to use too cool for my variable name. Put it in there. It gives me an answer of 0. That means no. In computer speak, 0 means no. But if I do isvar name I'm too cool, I am too cool, like that, I am too cool, and I do that, and the answer is 1. I can use that for a variable name, and that's great. So that's a useful feature if you're trying to name a variable something, you're not sure if it's allowed. So another one that you might check is isvar name sign. Let's try that one. It says yes, but there's a problem with that. It is actually also the name of a function in MATLAB. So it's not a good idea to use it. I would be careful using sign. But it does allow you to reassign that to equal sign. So you got to be careful. Another thing that you can do to check to see if something is usable, it's not being used already by MATLAB, is the function which. So just the word which, W-H-I-C-H. And if you ask MATLAB which I'm too cool, for example, it will say I'm too cool not found. MATLAB does not have a variable or a function that is called I'm too cool, so you can use it. But if you do the same thing and you ask for sign, it will tell you that it's a built-in function, and here's where it is. It's in this MATLAB toolbox, and it's being used. So you shouldn't use it. It's a very useful thing to do. Let's see. The last things that we need to cover when it comes to what MATLAB can do is the functions that you can use, some of the functions and the functionality that you can use with matrices, a couple of other built-in things, and just some examples of using this stuff to solve problems. And so when we get together next time on Wednesday, we'll start off with that, and then we'll answer questions about homework, and if we have any more time, then we'll move on to chapter 3. If we don't have time after we finish chapter 2, then we'll just do chapter 2 for a couple of weeks and move on to chapter 3 the next week. So we're done for today. Have an enjoyable week. Get started on your homework, see how far you can go, see what you can learn in the book. It's often good to have one window open to a web browser in your computer so that you can Google things really quickly. I highly recommend that. And don't forget to use comments in your code and good spaces in your code when you turn it in. Have a good day.
Is there anything there's like because like the thing says it's due tomorrow.
Yeah, there's no. If just ignore the due dates. Ignore the due dates in Blackboard.